morning. Welcome to btosacademy. Welcome to my maths class. Today is the second episode for the chapter inverse trigonometric function. I discussed up to serial number 11. Actually, I used the serial. Now, today it will be 12. We have still few formula or properties. I shall first discuss those properties, then sums will be discussed. Three sine inverse x is equal to sine inverse within brackets 3x minus 4x cube, then 3 cos inverse x is equal to cos inverse 4x cube minus 3x, then 3 tan inverse x is equal to tan inverse 3x minus x cube divided by 1 minus 3x square. These are the three formulae. I shall prove 1 or 2. Students, already I have told that you prove yourself the others. Then it will be very much positive matter for you. You will be very much skilled. First I prove this one. Let sine inverse x equal to theta. You see 3 sine inverse x, therefore we have to use the identity here for sine 3 theta. Sine inverse x equal to theta, therefore x equal to sine theta. Now sine 3 theta is equal to, already you have learned 3 sine theta minus 4 sine cube theta. In class 11 you have learned, now I put the values 3x minus 4x cube. Therefore 3 theta is equal to sine inverse 3x minus 4x cube. Therefore, theta is nothing but sine inverse x. Hence this formula, first formula is proved. Now I prove number 3. Let tan inverse x equal to theta, therefore x equal to tan theta. Now you have to use here the identity for tan 3 theta. Tan 3 theta is equal to 3 tan theta minus tan cube theta 1 minus 3 tan square theta. One thing already I have told in the earlier episode, that while you are working out sums on inverse trigonometric functions, you will actually practice the identities or formula of different area of trigonometry, uh, compound angle related identities, then multiple angle related identities like this. Here we are using sin 3 theta, then here it is tan 3 theta. Now I put the values 3x minus x cube 1 minus 3x square. Therefore 3 theta equal to tan inverse 3x minus x cube by 1 minus 3x square. Therefore 3 tan inverse x is equal to tan inverse 3x minus x cube 1 minus 3x square. And I suggest learner student you prove the second one yourself. Now I shall now find one important property for tan inverse x, rather 2 tan inverse x. Already I deduced one, but there are many others. That is why I go back, say 11 to tan inverse x. I shall find different forms of 2 tan inverse x. First of all, actually sin inverse, cos inverse, tan inverse, there are 3 forms. In the last class, I think I deduced tan inverse from. Now, sin inverse 2x by 1 plus x square, cos inverse 1 minus x square by 1 plus x square. If we express that in tan inverse form, it will be 2x by 1 minus x square. I prove first this one, next this one, then already I think I have deduced that, or you will deduce yourself. Therefore, tan theta equal to x. First sin inverse, that means we have to use sin 2 theta formula in terms of tan. Now, sin 2 theta 2 tan theta divided by 1 plus tan square theta. 2x by 1 plus x square. Therefore, 2 theta, that is equal to sin inverse 2x by 1 plus x square. Therefore, 2 tan inverse x is equal to sin inverse 2x by 1 plus x square. Therefore, 2 tan inverse x in terms of sine inverse I have expressed. Then for the second one, again cos 2 theta 1 minus tan square theta by 1 plus tan square theta. Actually, while we discuss trigonometric ratios of multiple angle, then I always encourage students to deduce the identities for sine 2 theta, cos 2 theta, tan 2 theta in terms of tan theta. Thus, cos 2 theta equal to 1 minus tan square theta by 1 plus tan square theta. We put the value of tan theta here, 1 minus x square by 1 plus x square. Therefore, 2 theta equal to cos inverse 1 minus x square by 1 plus x square. While we are reducing these forms or formulas, we always keep in mind that domains range are in suitable form, and I suggest student you reduce yourself this form, tan inverse form. Now I shall work out sums. I have taken here 3 sums. Those are actually very short questions. That is why I have written 3 sums at a time. Number 1. Now, first I shall mention the principal value range of the inverse functions taken here. Principal value range for sine inverse is let sine inverse root 3 by 2 equal to theta. Therefore, sine theta equal to root 3 by 2, and already you know that this is sine pi by 3. Keeping in mind the principal value range, theta equal to pi by 3. Therefore, finally we write the answer, sine inverse root 3 by 2 equal to pi by 3. Now for tan inverse, principal value range is minus pi by 2, pi by 2, open interval. In this case, closed interval, in this case, open interval. Let tan inverse 1 by root 3 equal to theta. Therefore, tan theta equal to 1 by root 3. Already you know standard angle matter, that is tan pi by 6. Therefore, theta equal to pi by 6. Therefore, tan inverse 1 by root 3 equal to pi by 6. Already I have mentioned that if it is not mentioned, then you consider that we have to find the principal value. Now sum number 3, for sec inverse, principal value range is 0 to pi minus set of pi by 2. Closed interval 0 to pi except the value pi by 2. Let sec inverse minus root 2 equal to theta. Therefore, sec theta equal to minus root 2 minus sec pi by 4 sec pi minus pi by 4. Therefore, sec theta equal to sec 3 pi by 4. Therefore, theta equal to 3 pi by 4. Sec inverse minus root 2 is equal to 3 pi by 4. Next sum, first I write here to find the value. Cos inverse half plus 2 sin inverse half. We have to find the value of this expression. Solution: principal value range for cos inverse is 0 pi closed interval principal value range for sin inverse is closed interval minus pi by 2 to pi by 2. Now we shall calculate the principal values for this and this, then add. Let cos inverse half is equal to alpha. Therefore, cos alpha equal to half cos pi by 3. Therefore, alpha equal to pi by 3. Let sin inverse half equal to beta sin beta equal to half sin pi by 6. Therefore, beta equal to pi by 6. Cos inverse half equal to pi by 3. Sin inverse half equal to pi by 6. Therefore, now I write the whole expression. Cos inverse half plus 2 sin inverse half, that is equal to pi by 3 plus 2 into pi by 6. After simplification, pi by 3. Therefore, finally 2 pi by 3. Now, I have taken in the serial of 3 two sums to find the values of. I suggest students, learners, in the initial stage you mention the principal value range, but it is not mandatory that you are to mention those principal value range, but it will be very much useful, you will be benefited rather if you mention principal value range. First I mention those. Principal value range for tan inverse is open interval minus pi by 2, pi by 2. Principal value range for cos inverse is closed interval 0, pi. Principal value range for sin inverse is closed interval minus pi by 2, pi by 2. Now I find values of each of these. Let tan inverse 1 equal to alpha. From that, tan alpha equal to 1 equal to tan pi by 4. Therefore, alpha equal to pi by 4. Cos inverse minus half equal to beta. Cos beta equal to minus half cos pi minus pi by 3. Therefore, beta equal to 2 pi by 3. Actually, keeping in mind the minus symbol, cos pi by 3 is half. Therefore, since the principal value range is this one, therefore we have written cos within brackets pi minus pi by 3. Then for sin inverse, gamma sin gamma is equal to minus half sin of minus pi by 6. Therefore, gamma equal to minus pi by 6. Now, I put the values. Therefore, tan inverse 1 plus cos inverse minus half plus sin inverse minus half is equal to tan inverse. I have not written here. Tan inverse 1 is equal to pi by 4 cos inverse minus half is equal to 2 pi by 3. Therefore, sin inverse minus half is equal to minus pi by 6. Therefore, pi by 4 plus 2 pi by 3 minus pi by 6. Pi plus 8 pi minus 2 pi. Nine pi by 12, 3 pi by 4. 3 pi by 4. Check the answer. This is the answer. Already I have mentioned that while you solve such type of problems, it is not compulsory that these are to be mentioned. You just keep in your mind the principal value matter, and my suggestion is that to remember this principal value range, just you remember like this: for sine function, first quadrant, fourth quadrant, principal value range; for cos function, first, second; for tan function, similar to sine function, but that will be open interval, minus pi by 2 to pi by 2. In case of sine, closed interval, minus pi by 2 to pi by 2. In case of cos inverse, 0 to pi. Similarly, for other inverses, cosec inverse, sec inverse, cot inverse, you remember in that way, then it will be easier. And for accurate values, it is better while you are solving problems in the initial stage, you mention this. Then you can remember easily. Now, let me solve this sum. Principal value range for cos inverse is 0, pi. Therefore, if cos inverse minus root 3 by 2 equal to theta, then cos theta equal to minus root 3 by 2 cos of pi minus pi by 6. Therefore, theta equal to pi by 6. Therefore, cos inverse minus root 3 by 2 plus pi by 6 is equal to cos within brackets 5 pi by 6 plus pi by 6, that means cos pi. Sum of 5 pi by 6 plus pi by 6 is pi, and cos pi equal to -1. That is the answer. First I solve this sum number 4. First of all, let us see the inverse functions within the brackets. Sine inverse 1 by 3, sec inverse 3. Now sec inverse 3 can be written as cos inverse 1 by 3. In that case, we get sine inverse x plus cos inverse x. Similarly, the inverse functions within the brackets in the second part. Sine of sine inverse 1 by 3 plus sec inverse 3 plus cos within brackets tan inverse half plus tan inverse 2. Sine within brackets sine inverse 1 by 3 plus cos inverse 1 by 3 plus cos of tan inverse half plus cot inverse half. You can write here the explanation. Since sec inverse 3 equal to say theta gives sec theta equal to 3, therefore cos theta equal to 1 by 3. From that we get theta equal to cos inverse 1 by 3. That is sec inverse 3 equal to cos inverse 1 by 3. While you practice, you show these steps like this. But already I have mentioned that this is not compulsory to show in case of examination. Therefore, the value will be sine inverse x plus cos inverse x when x is lying in between -1 and 1 is pi by 2. Sine pi by 2 plus cos pi by 2. Sine pi by 2 is 1 and this is 0. Therefore, the value is 1. This is the answer. Now, sum number 5. I first work out the value of the first two, then third, fourth, then add this. Number 5. Now, tan inverse 1 by 3 plus tan inverse 1 by 5 is equal to tan inverse. First I recall the formula for tan inverse x plus tan inverse y is equal to tan inverse within brackets numerator x plus y, denominator 1 minus xy. Here product of 1 by 3 and 1 by 5, that is less than 1. Therefore, formula will be denominator will be 1 minus xy, 1 by 3 plus 1 by 5 by 1 minus 1 by 3 into 1 by 5 tan inverse. Since the denominators will be same for numerator and denominator, I am not writing the denominator part. This will be 3 plus 5 and this will be 15 minus 1. That means tan inverse 8 by 14. On simplification it will be tan inverse 4 by 7. Now I calculate this one, these two. Tan inverse 1 by 7 plus tan inverse of 1 by 8 is equal to tan inverse 1 by 7 plus 1 by 8, 1 minus 1 by 7 into 1 by 8, tan inverse 15 by 55. That is tan inverse 3 by 11. Therefore, finally, given expression is equal to tan inverse 4 by 7 plus tan inverse 3 by 11. Now we apply that formula already mentioned earlier. 4 by 7 plus 3 by 11 by 1 minus 4 by 7 into 3 by 11. That is equal to tan inverse of denominator will be same. I am not writing that. 44 plus 21 by 77 minus 12. Tan inverse of 1, that is equal to pi by 4. Tan inverse of 65 by 65, that means tan inverse 1, that is equal to pi by 4. Next, I have taken two more sums. I solve now. Sec square cot inverse half. First I find the value of the first part, sec square, and within brackets there is cot inverse. Now if I first express sec square as 1 plus tan square, then it will be 1 plus tan square within brackets cot inverse half, that means tan inverse 2, that is equal to 1 plus tan of tan inverse 2 whole square. That is equal to 1 plus tan of tan inverse 2, that is 2 is to square here 5, and cosec square tan inverse 1 by 3. First I apply cosec square theta plus cot square theta. Cosec square theta equal to 1 plus cot square theta for 1 plus cot square. Now since there is cot, I convert that tan inverse 1 by 3 as or in the form cot inverse 3, that is equal to 1 plus cot of cot inverse 3 whole square. 1 plus cot of cot inverse 3 is 3 square. 1 plus 9, 10. Therefore, I write the whole 6 square within brackets cot inverse half plus cosec square within brackets tan inverse 1 by 3 is equal to 5 plus 10 equal to 50. That is the answer of the first one. Then number 7. LHS is equal to tan inverse 4 by 3 plus tan inverse 12 by 5. First I find the RHS is pi minus this part. Therefore, keeping pi is there in mind, we first write tan inverse 4 by 3. Actually, tan inverse x plus cot inverse x equal to pi by 2. Therefore, first I convert those into cot form. This is the first one plus pi by 2 minus cot inverse 12 by 5. Now we take these two, therefore pi minus within brackets cot inverse 4 by 3 plus cot inverse 12 by 5. Pi minus, we convert this in tan inverse form. Tan inverse 3 by 4 plus tan inverse 5 by 12. You convention here, since cot inverse x equal to tan inverse 1 by x. Now we apply formula tan inverse x plus tan inverse y formula. X plus y by 1 minus xy pi minus tan inverse. Not writing the denominator of both numerator and denominator. 36 plus 20, 48 minus 50. Pi minus tan inverse 56 by 33. That is the RHS part. Good. Already I have discussed almost all formulae or properties in the earlier episode. In this episode, I shall first deduce one formula, rather one set of formula first, then I shall start working out sums, and that one is to tan inverse x. We have different forms. I am writing down first sin inverse 2x by 1 plus x square, that is equal to cos inverse 1 minus x square by 1 plus x square. Then we have tan form, rather tan inverse form, we can also express in other inverse form. Mainly we use this, or these are used, that is why I am deducing this first. Let tan inverse x equal to theta. Let me remind you that while you are working out sums related to inverse trigonometric functions or trigonometric inverse function, then we consider the principal value range, not general values. Keeping those restrictions in mind, we work out different sums or different properties. Tan inverse x equal to theta, therefore tan theta equal to x. Now to get sin inverse form, we have to use here sin 2 theta, or to get this one we have to use cos 2 theta form, and to get this we have to use tan theta form. Actually sin 2 theta, cos 2 theta, tan 2 theta all can be expressed in terms of tan form. First, let me write down those. Number 1, sin 2 theta, 2 tan theta by 1 plus tan square theta. Number 2, cos 2 theta, 1 minus tan square theta by 1 plus tan square theta. Number 3, tan 2 theta, 2 tan theta, 1 plus tan square theta. I always encourage my students, while I discuss this, first you write down these relations, and the important thing is that if you deduced earlier, that means in class 11, then it is better. If you didn't do, or it may be that you have forgot, then it will be better you deduce this. Sin 2 theta has two forms one is sin cos related and the other is tan form. Cos 2 theta, it has four forms. The first one is cos square theta minus sin square theta, that is cos sin form. Second one is cos form, I say like this, cos 2 theta equal to 2 cos square theta minus 1. Then sin form, cos 2 theta equal to 1 minus 2 sin square theta. Then tan form, 1 minus tan square theta by 1 plus tan square theta. If you forgot, my suggestion is deduce this, it will be better. Then you can easily memorize. And tan theta, that is 2 tan theta by 1 plus tan square theta. These are multiple angle related, though we can deduce those with the help of trigonometrical ratios of compound angle. Okay, now let me work on this one. Already we have got tan theta. Now sin 2 theta, already I have written that 2 tan theta by 1 plus tan square theta. Now I put the value of tan theta, 2x by 1 plus x square. Therefore 2 theta equal to sin inverse 2x by 1 plus x square, means 2 tan inverse x is equal to sin inverse 2x by 1 plus x square. Next, cos 2 theta, 1 minus tan square theta by 1 plus tan square theta, 1 minus x square by 1 plus x square. Therefore 2 theta is equal to cos inverse 1 minus x square by 1 plus x square, that is 2 tan inverse x equal to cos inverse 1 minus x square by 1 plus x square. Next, the last form, tan 2 theta equal to 2 tan theta 1 minus tan square theta, put the values 2x by 1 minus x square. Therefore 2 theta equal to tan inverse 2x by 1 minus x square, that is 2 tan inverse x is equal to tan inverse 2x by 1 minus x square. One thing you note, in case of sin inverse form, numerator 2x, in case of tan inverse, numerator 2x, in case of sin inverse, denominator is 1 plus x square, here it is 1 minus x square. Remember that. That is the difference. Looks similar, but in case of sin inverse it is 1 plus x square, but in case of tan inverse it is at the denominator 1 minus x square. Next, these sums. I have marked here sum number 1, taken 4 parts. Actually, we have to find the principal values of these inverse forms. We take this equal to theta. Therefore, sine theta equal to root 3 by 2. Already you know sine theta, when sine theta equal to root 3 by 2, theta is pi by 3, 60 degree or pi by 3. Therefore, theta equal to pi by 3, and principal value for this sine inverse is minus pi by 2 to pi by 2. Keep it in your mind. Therefore, theta equal to pi by 3, that is sine inverse root 3 by 2 equal to pi by 3. Number 2, cos inverse half equal to theta. Therefore, cos theta equal to half. Already you know cos 60 degree, that is pi by 3 radian. Therefore, theta equal to pi by 3. And in case of cosine function, principal value is 0 to pi. Therefore, theta equal to pi by 3, that means cos inverse half equal to pi by 3. Then I have taken tan inverse form, 1 by root 3 equal to theta. Therefore, tan theta equal to 1 by root 3, tan 30 degree or pi by 6, and for tan function, principal value will be minus pi by 2 to pi by 2, open interval. Therefore, theta equal to pi by 6, tan inverse 1 by root 3 equal to pi by 6. Then we have sec inverse. Therefore, sec theta equal to minus root 2. Therefore, cos theta equal to minus 1 by root 2. We have converted to cosine, and we know that principal value interval is this. Sorry, it will be closed, and cos of I minus 1 by root 2 means pi by 4. Thus, we have calculated some inverse form of different trigonometric ratios. Now, my suggestion that while you are calculating these, you better initially you write the principal value range of each inverse function. then it will be uh, easier to find the principal value of each of these. Next, I am going to find the value of this one. If it is not mentioned in the question paper, always consider we have to consider the principal value. Then you can mention on the right side for tan inverse minus pi by 2 to pi by 2 principal value range, cos inverse 0 to pi, sin inverse minus pi by 2 to pi by 2 closed interval. Therefore, we can put the values mentally. Tan inverse 1, think like this, let tan inverse 1 equal to theta, then tan theta equal to 1, we know in that case theta equal to pi by 4. No need of showing those steps. I am putting here directly the values. This is pi by 4. Now for cos inverse, principal value interval 0 to pi, and also we know cos theta is negative in the second quadrant, therefore it will be pi minus pi by 3. Cos half, that is cos pi by 3, that is why I have written this. Then sin inverse negative, we know for sin inverse minus pi by 2 pi by 2 both inclusive, therefore it will be sin inverse half, therefore sin theta equal to half, and minus half, it will be negative angle, that is minus pi by 6. Pi by 4 plus 2 pi by 3 minus pi by 6. LCM of 3, 4, 6 is 12. 3 pi plus 4 pi minus 2 pi. 5 pi by 12. Oh, sorry, it will be 8 pi. This will be 9 pi. I think you have started this class as I have mentioned earlier. You sit with your copy and pen or writing instruments and solve as I am progressing. Don't think that this matter is to be just for viewing. If you want to improve your mathematical skill, it is better while you are attending such type of classes, online classes, my suggestion is that you take copy and pen or pencil and do as the teacher is performing. Therefore, I solved this sum. Also, another suggestion for you, that while you are practicing these sums, don't think that these are matters of memorization. You will always try alternative method. Then next matter, I take 3 sin inverse x, 3 cos inverse x, 3 tan inverse forms. I have not discussed yet. You can consider these as problems to be solved or sum. Then sum 3 to 3 sin inverse x is equal to sin inverse 3x minus 4x cubed. Let sin inverse x equal to theta. Therefore, sin theta equal to x. Since it is 3 sin inverse x, that means in place of sin inverse x it is theta. Therefore, finally it is 3 theta. Therefore, we are to use sin 3 theta for. Now, sin 3 theta equal to 3 sin theta minus 4 sin cube theta. We put the values of sin theta. Therefore, it is 3x minus 4x cube. Therefore, 3 theta is equal to sin inverse within brackets 3x minus 4x cube, that is 3 sin inverse x is equal to sin inverse 3x minus 4x cube. Already this one has been proved. One thing here, interval for x is minus half less than equal to x less than equal to